Hello everyone and welcome to another episode of Solving Advent of Code in Rust and Python and try to learn Rust in between. I am Roberto and we have
Luciano, hello.
thank you everybody for following along. If you never did Advent of Code, Advent of Code is a challenge that is published every year around the Christmas period. We are working toward the last year's one. There are 24 challenges. You can find them on adventofcode.com. There. We are publishing all our code in a GitHub repository, this one. And we have a YouTube channel where we publish all the recording. You can find the link in the description of the Twitch channel. We left off last episode with exercise day 9. We did it, finished it. Okay.
Yes.
So today we are doing day 10.
Let me show you the Readme. So today I'm gonna skip all the verbose stuff and give you kind of a summarized version because this is very long. But basically today's challenge is a parenthesis matching challenge. So something that actually interesting because very common in coding interviews. So we get to do it in the context of Advent of Code, and there are some nuances that we need to take care of. And basically, what we do is we will have as an input something that looks like this. So every line is a sequence of parentheses. And the kind of parentheses that we can have are parentheses, brackets, curly brackets, angular brackets. I hope my English is good enough. And of course, every parenthesis has a matching one, open and close parentheses. So those expressions basically, they need to be balanced. We need to have balanced parentheses. But not all the lines have correct expressions. So we can have lines that are where all the parentheses are balanced, so all the opening and closing parentheses are matching. We can have lines that are incomplete, so maybe where we are missing the closing parentheses. And we can have lines that are wrong, so where effectively when we close a parenthesis, that parenthesis is not matching the respective opening one. So we have some examples here. So here in this one, for instance, we expected at some point closing square bracket, and if we found a curly one instead. Here we expected a closing square bracket, we found a round one instead, and so on. So these are cases where the expression is effectively broken. Now, another interesting point is that there is a syntax error score, which is basically every time there is this kind of parenthesis is 3 points, this is 57 points, and different scoring. So what we need to do in the first part of the exercise is we need to find the first illegal character in each corrupted line. So we only need to find the corrupted lines, so the ones that are actually broken, not the incomplete one, not the correct ones. And then we need to find the error score for that line. And finally, we need to sum all the error scores. Does that make sense?
Yes, to me.
Cool. So should we read also part 2, or we want to start to see the solution?
Let's see the solution for part 1. Today we are doing something a little bit different. We are showing a Python solution for this, and then we are jumping in the Rust one.
So Roberto, you are going to lead the Python one because you are the Python expert.
Okay. To do this, it's in Italian, sorry, but well, code is code. The user interface is. Can I put the user interface in English? Probably not the best one. Okay, let's minimize, so it's not misleading anybody. Here, what we can see is the input. My input can be different from the Luciano ones. Remember this? This was my input, and in Advent of Code, every input is different. So,
yeah, also the solutions, of course, might be.
Yeah, and so the numbers can be different. I don't think they have a different input for all the people that is going in challenge, but there will be, I don't know how many of them. In any case, Python solution is this one. We have the score that comes from the Readme. Okay. 357, 1197, and 25,000 and whatever. Here we have two maps, two dictionary in Python that map the character to a number. So we have 1, 2, 3, and 4. If I find angular bracket, is going to be the key that points to a 1, square 1 points to 2, the curly 1 points to a 3, the round 1 points to a 4. Same for the closing one, 1, 2, 3, 4. Obviously, the 1 is the angular bracket opening in a dictionary and the closing angular bracket in the other dictionary.
So basically, because you are using a zip, you are building tuples of indices.
And from the tuple, I'm creating the dictionaries.
Okay.
Yeah, I could have just written this like this one, hard coding it, but I'm lazy. So I used a dictionary comprehension to have it done for me.
And also you're naming map, and map 2 is like open parentheses is map.
Yeah, sorry guys. This was not meant to be shown. This was for internal use only. But it's a coding style. Come on, you are declaring it there, using it 3 lines below. You remember what it is. I take my input, I split by lines without keeping the carriage return, and I have the line. For every line, I create a stack object that is a list. It could have been the queue. Again, lazy. I don't want to import the queue from collections. Is a list. For every character in the line, if the character is an opening brackets, I append the value 1, 2, 3, or 4 to the stack. Else, the here could have been an else, but just to be agnostic about the input. So if the input is not containing brackets, I only look for brackets. So if the character is a closing bracket, because it's in this other map, we can rename them, to be honest. I take the last number that I have in the stack, and I say, is the last number that I have in the stack different from the number that I'm on? So if I'm on a square bracket, it must be a 2. And the number I'm taking from the stack must be a 2. If this is not true, so if they are different, it means that this line is corrupted. If this line is corrupted, I add this score, that comes from this table, to my return, that is my solution. And in the end, I can break on this line because I have nothing to do anymore on this line. I go to the next line and I loop. When I'm out of this loop, I have my solution that probably is different from yours, Luciano, but because I think it's another number, because it's another input. So this is the Python solution. The scores are needed. I created an association, an enumeration between brackets and number, and brackets, closed brackets to number and open brackets to number. I go with a stack on top of every line, of every character of the line. If it's open, I add it to the stack. If it's closed, I pop from the stack, and I check if I popped something that is legit. If it's not legit, I count the syntax error score, and I go on. Cool?
Sounds good. Perfect.
Okay, let's see the Rust counterpart of this.
Yes, and then I think you can also meanwhile grab my input, and then we can check that we get the same input, but I'm confident that your solution works.
Oh, well, we can do this. We'll share your
While
screen
you do
and show
that,
us
yeah,
while
absolutely.
I do this. Yeah.
Okay, so let me switch to Rust. So, of course, the Rust solution is going to be a little bit more verbose, but I think in principle is a very similar implementation. Also, I think I have a little bit more generalization also to cover part 2, so we can probably ignore some of the stuff. But the first thing that I want to mention is that here, what we are going to do is that during our parsing, we are going to be able to use error types. And if you ever done error handling in Rust, you know that it can get pretty verbose. So there is a crate that you can use that is called thiserror. And this error basically gives you derive macro and other annotation macros that you can use to basically define your enum errors. And in this case, what we are doing, we are defining a generic enum that is like a parse error, and that contains all the different type of failures that we can have while parsing. And we know that we have only two types of failure: when it's incomplete and when it's corrupted. Now, when it's corrupted is the actual error case we are interested in for part 1. And basically what we do is this particular variant of the enum will contain the two tokens that are not matching. So, and in fact, what you can see that with this error crate, you can also easily define the error messages. And here, what we are going to say when this error happens is expression corrupted, expected 0, which means the first item included here, but found 1, which is the second one included here. So this could be something like expected a closing curly brackets, instead found a round bracket. Now, here we also have an enum that lists all the possible token that we can find in this expression. And I just call them open 1, close 1, open 2, close 2. And here I have comments that map what I expect them to be. So this is open round parentheses and so on. And my matching here is literally open 1 matches close 1 and so on. Now I also have a display just in case we want to visualize the parentheses, and this is going to be used here in this error message. But I also have a from char, which allows me to create the enum variant from the actual character that we are going to find in the string. And this guy also handles this case. We could have done a very specific error. This could have returned an additional error type that was invalid character. Honestly, we know that the input is going to be sane in that sense, so I didn't bother creating another error type. I just made this unreachable. So if the code is going to get here, it's actually going to panic, telling us I was not supposed to reach here. A better, more production-ready implementation would have been define another type of error here, like invalid character, and return that particular error variant here. I also created another utility function directly implemented in the token type. So every time you have a parenthesis, you can call this matching function on the parenthesis token, and it will give you the equivalent matching parenthesis. So if you have an open parenthesis, it will give you the close one. If you have the close one, it will give you the open one. So this is something similar to what you, Roberto, did with your map.
Yeah, with the dictionaries.
But this one allows us to use it in a more object-oriented way. So we already have the token. We can just say dot matching, and it will give us the other token. And then I also created this expression matches, where basically if you have a token and you pass it another token, it will give you true or false. Basically, if you're giving an open parenthesis and you give it the respective closing parenthesis, it will give you true. Otherwise, will give you false. And then I have is open and is closed, which are other utilities that from a token, they can tell you, is it an opening one or is it a closing one? And finally, for the error score, it's again based on so it's in the token itself, it's a method of the token, and it can give you an option you side. So only if it's a closing parenthesis, it will give you the score. If it's an open parenthesis, you'll get none. This one, let's ignore it for now because this is useful for part 2. Does all make sense so far? So we only define expression, error types, and token types, and a bunch of helper functions.
So you basically define that every time I have a character, I can create a token from it, and the token has abilities, properties, function, members.
Now this is where it starts to get interesting, and I think that here I have already a more generalized solution. Yes, so there are things here that we can probably ignore, but let's go through it anyway. So this is a generic function that takes a line and it gives you as a result that it can be either a parse error. So in case that the expression is not valid, it's going to get a parse error, and it's going to be one of the two types. Either is incomplete or is actually malformatted. But if it's all good, what we get is a vector of tokens. So as it goes through, accumulates a vector of tokens, and if all the expression is fine, it returns the result okay with the vector of tokens. Otherwise, you will get a parse error. Then we create a stack. In this case, I'm using a vector queue of tokens. By default, is empty. And then I have also a vector of tokens. Now, so this is basically all the tokens that we keep finding as we scan. So we never delete or remove anything from here. Instead, this is the stack that we are going to use to match parentheses. So that this is why we keep two. Okay, so let's start. What do we do? For every single character, so we read the input as a sequence of characters, and we get the current token by just calling C into. And we can do that because we implemented the from trait from a character. We know how to build a token. So this is what gonna do exactly that. Then we push the current token in the list of tokens, because in the case that everything goes well, we just want to return the list of tokens as a vector. And here is where we start to do all our inner workings. So we say, if, so what we do is we pop back from the stack. And in this case, like in the first iteration, this is going to be empty. So the first iteration is going to ignore this one. But let's say from the second iteration on, we're going to have something in the stack. So we get that something from the stack, and we check if there is something, we call it expected. Then what we do is, if the current token is a closing token, so if it's a closing parenthesis, and it doesn't match the latest parenthesis that we took from the stack, what we're going to do is, this is a corrupted case, so we just build the error type and return that, saying we were expecting this guy, but in reality we found this other token. Does that make sense?
You are always pushing to the stack of the token.
Mm-hmm. I am pushing back, yeah.
Okay.
And then here we are using pop back.
Okay, instead, if it's not a closing one, you just add it.
So what we do, so here is the case that is not matching.
Okay.
The other case is re-add the token to the top of the stack and add the new token as well.
Okay, so in the stack, you will always have everything, even the open tokens. So you go on removing, then throwing an error, or add and remove. Cioè, remove, add and add. So remove, add, remove, add. If there are no errors. If there is an error, is remove error, let's go.
Exactly. And then the else case, which is pretty much when you have opening parentheses, because, or actually, this is going to be
the
only
first
at
character.
The first character, you just push it.
Okay. In my solution, I keep a stack of the level, only of the level of, or only of the types of the brackets. I mean, I don't keep the open one or the closing one. I just keep the number that is the logical level. I mean.
Mm-hmm. which is probably a more memory efficient solution. I think here I wanted to have a comprehensive view, but I don't think it's really needed for the
Yeah, because you're
exercise.
removing, then adding, removing, adding. In the end, you're adding.
Exactly, yeah. So let's
Is
leave
there
that
not
aside.
a way? Is there not a way in Rust to just take a look at what's the last element of that stack?
We can check that. There is probably like a peak back or something like that.
That probably
Let's leave
tells.
that as an optimization for
So you don't have to add it back because you're always or
let's
erroring
see.
or adding it back. So
Peak. Is there a peak?
or stack is at the queue, you said.
Yes, it's a vector queue.
So you
There
can't.
is back. Back, I think. What does it do back? Does it just give you provides a reference to the back element if known? Okay, that this is what we want. And I think at this point we don't need to re-add.
Okay.
Right?
Yeah. Back. Okay.
And
From the name back, I would never have guessed that was the last element of the queue.
that's what it seems from
Yeah, I
the
see that
document.
one from the description. It's just that the name is not very expressive. Say the guy that called the dictionary map and map 2.
Exactly.
So, okay.
So add new token to the stack. Okay, and this one, let's say that we can remove it. We'll run the test and see if it works. So, okay, then the last thing that we need to do is that if we get to the end, so if we checked every single character and then the stack is not empty, then it means that there were no matching brackets.
Because when you match the brackets, you remove.
Oh yeah, I think then we might still
You have
need
to
to do
remove
that.
both of them.
Yep.
When is that? Where is that you match the brackets?
I think it's here is an else statement that is not here. So I think that in this case we need to pop anyway.
Yeah, if it's a close brackets and is matching, we have to pop twice or just once.
Just once because we don't re-add.
Okay,
but we need to pop back basically. So in this case we need to do tokens. Now what is it called?
Stack token.
Pop back.
Yeah, but why now is complaining about expected?
Here. It's complaining about expected.
Because back is not giving you the element. Back is giving you a reference to the element.
Oh, okay. So we need to. Do we need to dereference it?
Matches make sense to accept a reference, not a token.
Yeah, I'm afraid that if we do this, okay, it doesn't complain.
No, but the declaration of the function matches makes sense to accept a reference, not a real instance of the token.
Actually, yes, we could change it that way. And it's
leave accept that is already a
reference, and we
accept
can
a reference in match.
Yep.
Because what is the rule in Rust? If you just need to read the value of something, pass it as a reference. It's not pass the full object, right? So you don't take ownership of that token because you don't need to take ownership.
Exactly. I'm not really sure what happens here with the referencing it. I think it might depend on the type, whether this takes ownership or not.
Because that self-matching, what is again? Sorry, I forgot.
Self-matching just gives you a new token, basically, that is the matching one. So you're kind of creating a copy.
Yeah,
Yeah, we could have got, I don't know, like global references to avoid always creating new tokens. But because these tokens are only containing a char, I thought this would make things simpler, not to having to deal with references.
Okay, let's see if we broke everything.
Yeah, let's see. So here now is happy. Everything else seems to be matching.
You were in line 138. If the stack is empty,
If the stack is empty, at this point it
it's not
means...
empty, sorry.
So if it's not empty, it means that there is some left over. So we are incomplete. So we didn't
we
find
need to
all the
close.
closing brackets. And then if that's not the case, everything is okay, and we just return the list of tokens that we found.
Returning the list of tokens is not something strictly required from the README, right?
No. It's just something that I did, I suppose, for debugging, or maybe useful for part 2. I'm not really sure.
Okay.
Okay, so let's see part 1. So part 1, so that was only parsing one line. This is parsing the entire input. So we get the entire input, we split that by lines, we do a filter map, we do this thing where basically we say parse an expression, so parse the current line as an expression, and we get back a result. Now, if that result is an error, and if the error is of type corrupted, this is what we are looking for in part 1. So this is matching. It needs to be an error and an error of type corrupted. We don't care of what was the expected one. We only care about the token that was actually found. So this expression will give us the parenthesis that was found that was breaking the expression. And what we do, we just return the error score of that parenthesis. So this is doing a filter map. So it's basically a quick way to do both a filter and a map. And you have to return either some value or none. When you return none, it's just filtering out that value. When you return some, you are taking the current value and mapping it to a new value, which is what we are doing here. So either is none, which means that it was either okay or it was incomplete. Or in the case that we return here, we are returning a some other value, and that's the value that is gonna be mapped to the final result. And then at the end, we just sum all of that.
For part 1, we are returning in that return when there was an error.
In that return here?
Yeah, when there is a closing bracket not matching an open one.
Exactly. And then error score, remember that returns an option usize. So basically, at the end of the day, this filter map is trying to give us a list of usizes, right? It's just gonna keep the ones that are some usides, and then at the end we sum all of them. Make sense?
Yes.
Okay, let's see if it works now, or if we
changed something. Let's see if.
So we have a bunch of tests just to test parsing expression. So that should tell us already if we broke something. Okay, we didn't break anything. And now we can test. I did a bunch of tests here. This is for part 2. Okay, let's test part 1. Nice. Seems to be working. And by the way, for part 1, this was my output. If you want to check that you did the same.
Yeah, it's doing the same now. I can show you. I'm also putting names that are a little bit more nice. So name, the number I think is the same.
Yeah, 392367. Yes, that's the same.
Cool. Code is the same as before. I just rename it because it's better. Open brackets, close the brackets. Char is the character. The bracket type is what I take from the stack. If the bracket type is different from the one that I'm closing, it means that it's corrupted. If it's corrupted, I add to the error score, and in the end, I show the error score. Also, I changed this to something more readable. So enumerate this string of brackets, and that is the index and C, and start from 0. So I add 1. In theory, this is not even needed because this is just mapping to a number. I think this is just the same. Yeah, same number. And from the number and the character, I create a dictionary from the character to the number. So I need it the other way around. and I have my 2 dictionaries that I use in my 4. And
Perfect.
it's giving the same number, so it's fine. Do we want to read part 2?
Yes, let's go to part 2. Let me share my screen again.
And we also
Okay,
changed
so
some code without destroying your solution.
nice. So
Nice.
part 2 is same problem, of course. There will be only a slight variation. And basically what we want to do, if I remember correctly, is trying to autocomplete the lines that are not complete. Let's see if I remember correctly.
I think so. And we have to compute scores.
And the scores are now different, where the points are 1, 2, 3, 4 based on the type of closing parenthesis. So as we add the missing parentheses, we will be able to compute some particular score depending on the type of parenthesis we add. Okay. I don't remember this part here. Multiply the total score by 5 to get 0.
For every line, you will have to close a bunch of parentheses to be balanced. You have to start to close them and keep an accumulator. Every time that you close a bracket, you multiply the accumulator by 5 and you add the score of that bracket. Then you take the next bracket,
so that's why you multiply by 5.
multiply the accumulator by 5 and you add the score and so on.
So you don't just sum all these values, but every time you every time you find a new bracket, you first multiply everything by 5 and then add the score of the parentheses you need.
It's basically a base 5 conversion. And the brackets are the 4-digit of this base 5 notation, and the 0 is not there because there is nothing that is worth 0. But basically, it's converting from base 5 to base 10.
Okay, so what we need to do now is autocomplete tools are a not bunch. Okay, blah blah. Find the completion string for each incomplete line and score the completion string and sort the scores. What is the middle score? So, okay, there is a little bit more that we need to do compared to the previous part. So now we only care about the lines that are incomplete. We should complete all the lines that are incomplete. For every line, we calculate the score. Then we need to sort all these lines.
The scores.
And our puzzle answer is the score in the middle.
Yeah.
Do we want to look at the Python solution first?
Yes, I'm getting a different number this time. But well, let's see if we can look at your puzzle answer is a number that is probably different. Let me try to see.
Slightly different.
Okay.
Maybe we're just taking something in the middle in a different way.
Let's try to follow the logic here and see if we have something different there. So again, we have our open brackets, we have our closed brackets. Let's check the scores with the readme. Angular brackets is 1. No, it's not. My scores are wrong. Tell me in the readme the order of the
round brackets is 1, square brackets is 2, curly brackets is 3. Round first, square, curly, angular.
Okay, the error was this one. Curly and angular. Okay, we hit this. Let's see if now the numbers are matching.
I think so. 21921041158. Yes.
Okay, good. Almost there. So the code is the same as before. This one is exactly the same as before. We added the scores that keep track of all the scores for every line. We compute the line score instead of computing the error score. Here, for every line, we check if it's corrupted. If it's corrupted, we break and we go to the next line. If it's not corrupted, can be empty or with something left over. And in Python, a for else means you land here if the for used all the elements without hitting a break. So it means that here our stack is empty because the expression is well formatted, or there are leftovers. In any case, my line score is 0. If stack is empty, it's not going in here, it's appending a score of 0. Done. If there is something in the stack, I take my line score, I multiply that by 5 because it's written in the README. I sum what is in the stack. And in the stack, remember, I don't put the chars in the stack. In the stack, I put the bracket type that is 1, 2, 3, or 4. So I am already ready to compute the line score from what's in the stack. And popping from the stack, I go out of this while, I exit from this while when I'm run out of stuff in the stack. At the end, my line score will be the solution for this line, only for this line, because we have to add it to the scores. After we did all of this, we sort the score and we take the one in the middle. And now that I put the correct scoring up here, the numbers are matching. So in theory, I could make a generic function to do this and reuse the code here. Here I copy and pasted because it's not a huge amount of code, and yes, because it's not.
Yeah, this will be something similar to our parse expression if you generalize in a function, right?
Yeah, I generalize this one, giving me back a stack or empty or an error, and then here I just have back my error score, and I compute the error score. Otherwise, I take what's left in the stack and I compute the line score from the stack.
That's pretty cool. That double slash, is that an integer division in Python?
Yes, this is an integer division because this is Python 3. And if there is an odd number of elements in the list, it will give me back a float, and you can't index with a float, and that will throw an exception. The double here is forcing an integer division. And there's a difference between Python 2. In Python 2, this was the integer division. This was an integer division, and to do a float division, you had to write something like that to force the one on the right to be a float. Instead, in Python 3, they say, okay, slash is always gives you floats. Double slash gives you integer division.
Okay. Cool.
Now, Rust.
Let's try to have a look at Rust.
So it's time for Rust to shine, if this makes sense.
We need to polish some Rust.
Yeah, we have to polish some Rust to make it shine.
Okay, I want to start by looking at part 2, actually. And then we'll look at the specific functions that we did. So, okay, so here we have... let's see what we did. We did autocomplete scores, which is a mutable list that is initialized with the input mapped by lines. We filter map again. Now this time we look for incomplete ones in our match expression. So everything else in this filter map is the same as before.
Is discarded.
So we do the parsing, we get the result, and then we try to match only the ones that are incomplete. We know that when we get an incomplete error, that incomplete error will also give us a reference to the stack. So the stack at the time when we finish the incomplete expression. So this is how we get access to the stack, with coming from the generic parsing function. Then at this point, what we do is we try to create a completion sequence, and we have a function that does that. So maybe time to zoom into that.
Or we can show it later.
Okay, let's assume that this is magic for now. We'll check it
Yeah.
later. So this will give us a completion sequence, so which is literally just a sequence, a vector of tokens. So all the parentheses that completes our expression in the right order. And then what we need to do is we need to do that calculation of the score. So the way we did it here is by using a reduce. In Rust, it's called fold. So you iterate over a vector, you call fold, and you need to define what is the init value. And in this case, it's at 0 usides. And then the function that does the reduce. In this function, you get two arguments, the current value of the accumulator and the current token. And what we do, we always multiply the accumulator by 5 first, and then we add the score of the current token. And we have a function called autocomplete score that just gives you that value. We can also
Yeah, I
look at
think
this
autocomplete score is a quite simple function.
The only thing is that it's an option usides because it's generic, so it takes account also open parentheses. So for open parentheses, always returns none. For closing parentheses, it will return sum and the given score
And
for
the
that
number.
parenthesis. So that's why we
So
need
you
to
have
call
to unwrap
unwrap. And it's safe to unwrap here because we get here only with a sequence of closing parentheses, assuming that this magic function is implemented
works.
correct. And then at the end, we just return sum autocomplete score. And again, the reason why we return sum is because this is a filter map. So filter map returns a none if you want to discard that record, or sum a specific value if you want to take that record and map it to something else.
Why autocomplete scores is mutable?
Autocomplete score is mutable. Is it? It's not.
170. Let mut.
Oh, this is autocomplete scores.
Scores. Sorry.
I don't think it needs to be mutable. Oh, it is mutable because then we do sorting later on. That's why.
True. Right.
So this
right.
will collect all the values. So all the individual score,
right.
one per line.
Yes.
So and we do a collect here. So filter map will just give us all the values, and then we materialize all of that with collect. So this actually triggers the computation. At that point, we have an array of numbers, a vector of numbers. What we need to do is we take the element that we care about, the position of the element we care about, so by just dividing the length by 2. And here we are using an interesting function that you might remember from a previous episode, which is kind of a nice shortcut that you get in Rust whenever you need to take the median of a vector of numbers. This function is going to do a sort unstable and give you the middle element. Actually, you get the middle element and the 2 on the side. So you get actually a tuple of 3 items. If we only care...
the vectors on the side and the element in the middle.
Exactly. We only care about the element in the middle, so we ignore the 2 elements on the side. We call the one in the middle median, and we return. This will give us a reference, so we kind of return.
Okay, so it must be mutable because that select ent unstable needs a mutable object to work on.
Because it will do a sort, yeah.
Okay.
I think
and
it will probably do a smart sort. I think it will do an unstable sort, which I think is more efficient for numbers. And then will give us the element in the middle.
And it's giving you back a pointer to a reference to a usize. Makes sense. Mm-hmm. Why mutable reference to an usize?
Good question. Maybe because you might want to use this function to change this value. Here we are just returning.
To change the median inside the original vector.
Yeah, here we could have done something like, I don't know, 5, right? If you wanted to replace the median. So I think it gives you that capability.
Nice. So nice. I don't know when to use it, but nice to have it.
Yeah, they could have done 2 functions. Like it's common in Rust that sometimes you have 2 functions. You would have select and unstable underscore mute, and that will give you the mutable reference. Otherwise, if you don't pass mute, you get not just a reference. But here they decided to give you straight away a mutable reference. I'm not really sure what's the thinking behind it, but yeah.
And the magic function?
Let's look at the completion sequence, which is probably the most interesting part. So everything else we saw is just taking for granted that we got the right sequence and doing all the accounting for it. But how do we get the right sequence? So we start from a mutable vector queue of tokens. And this is the entire stack. So as we went through our expression, we built the stack. Every matching parenthesis was removing the two parentheses. So we are left only with a sequence of open parentheses that were not completed. And we want to return a vector of tokens, and this vector of tokens is all the sequence of parentheses that will finish our expression correctly. So every parenthesis will close the respective open parentheses, and we add all of them into this vector. So we start by creating this completion sequence as a mutable vector that initially is empty. Then we do while this stack is not empty. So while we have elements in the source stack, what we do is we pop back. We are sure there is an item, so we can wrap, and we just get matching. So we take the pop back parenthesis, we take the respective matching parentheses, and that's the value that will close the expression correctly. So we add
so
that.
we are doing a mapping in the end.
I suppose we could have used a map. Actually, we can try to rewrite that way.
We take it from the back and we push it in the front.
We push it in another in the completion sequence.
Yeah, in the front of another, but we take from the back of the stack. So if we map, we also have to reverse one of the two.
Which I think we can do. Let's see if this implementation is correct, which I think it is because we tested it. But
Yeah,
then
we changed something before, so let's see if it's still correct.
Yeah, so let's make sure that part 2 runs correctly, and then we'll try to do with an iterator, with a map, basically. Okay, so this is still working.
Still working even if we changed something, but well, we made it more efficient.
In the parsing. Now here what we want to do is basically what you are suggesting. I'm going to comment all of that. And what we want to return is literally just saying stack.iter.rev, then map. And what we want to do is we get a token.
Can you pass the function as a static?
The function as a static. I'm not sure
Class
what you mean.
colon the function.
You could, I think. Yes, actually, I think Rust Analyzer is going to suggest that. But before that, I think we have a question in the chat. Let me see. Why let some items stack pop back?
Instead of
we could have done that as well. Yes.
Instead of while the stack is not empty, while I was able to take something from the stack, do this other.
Yeah, rather than doing while it's empty. But let's try this one first. So here, what we want to do is literally just say token matching.
Yeah. And my question here was, can I write a token with the capital T colon matching?
I think we can. I'm not sure why Rust Analyzer is not suggesting that. Maybe because there is a reference here.
Okay. Question 1 is working.
Let's see if it's working. Yes.
That is the first big question that we have.
It is still working. That's good. Now I'm curious to try what you just suggested, which I think is something like this. Token dot matching
without the parentheses.
With self?
No, with self.
Without the parentheses, I think. I
was thinking with nothing.
Yeah, I was thinking like this, and it's not complaining, so I think that's the right syntax. And let's try again. Yeah, that works. Sometimes Rust Analyzer suggests that, so either my Rust Analyzer is dead or I don't know, whatever. Cool. So I
Last
think I like
analyzer
this one
gave up.
more. I think I like this approach more. Okay, so we have our both solutions. I don't know if there is any question from the chat. Your result was the same. We already checked that.
Yes, my result was the same.
I'm not
But
sure if there
way
is
less
anything
code.
worth improving here.
Don't know, because your solution has way more is more complete. I mean, because you created types for the open one, the closed one. You have a clear distinction of the two. Obviously, aside that the Python one that I wrote was not to showcase Python, it was just to get an answer, so get to the answer when I was doing Advent of Code. So yes, it's slightly different approach. But I think that having all the types in place and the matching and the parsing, and also in the stack, you don't have just the level, but you have also the tokens themselves. Like I said, is more complete.
Yeah, and one thing that we could have done, maybe we can quickly showcase that, is the case where you have an invalid character. And we can also build an example that shows that once we have all this typing system and different error variants, we could even make it more complete in that sense. We could start to build more rules around error checking. Does it make sense to do that? What do you think?
Try to show it, because I have no idea
Okay.
how to do that.
Yeah,
You have to do it.
So basically what we want to do is to parse error. It's an enum that tries to represent all the possible types of errors that can happen while we parse our expression. One case that we kind of ignored in a sneaky way, because we know our input, so we said, okay, let's write the minimum amount of code we can possibly write. But if we wanted to build a proper production ready solution, it's not guaranteed that our input is going to be correct. It's going to be only made of parentheses. There can be spaces or any other character, really. So if we really want to be complete, another error case could be invalid character, invalid char, let's call it. And we can use a char here just to have a descriptive error message. And with this crate, this error, it's called the crate, you have nice ways to build the two strings if you want to display an exception when it's happening. So you just need to use this error here, and then you can specify a string like found invalid character, for instance, and you can even use this 0 that says take the first value embedded in the error variant and do a toString of it and use it to build the error message. So now that we have this invalid character error, what we can do is that here where we did our parse functionality, here I think, yeah, we did this from string. One thing that we could do is that we can make this one fallible. So when you do a from is not, like, it assumes that the from is always successful, that you're not failing. So we need to use a different trait, which I think is called try from. If I remember correctly, we might have to import it.
And
Okay, yeah.
So the function is not called the from anymore.
But it's called try from, and we need to specify the error type. So the error type is parse error. So this function can return a result of self, which is going to be a token, or a self error, which is going to be a parse error. So let's copy all the stuff from here.
Okay, so line 62, that now is line
sorry, let me do
47.
this.
Yeah, now that we are stopped is line
So
47.
all this stuff is gonna be an okay of all of this.
Multi-cursor.
Yeah, we need to do it multi-cursor style. So okay of this. And here, rather than doing an unreachable, now we can return R, where error is our error type, which is parse error and invalid character. And here we can just say, for instance, C and C.
So we are passing an instance of the error.
Here is called char, that's why it doesn't match. Why you are not happy with it?
It's called a value.
Sorry. I needed to change this to C. Okay. So now at this point, we implemented the try from trait, but our code is broken at this point because we were assuming we were using the from trait, but we only have the try from.
Just a question here. The line 47, the type alias, basically, because line 47 is just a type alias in the end.
So this is called associated types. So
Okay.
in Rust, you have two types of generics. You have generics like this one here, a char. So when you have a type that contains other types and that in nested type, you can change it in based on how you want to use the original type. Like you have this wrapper type and you can specify the inner type. And then you have associated types, which are more in the context of traits. And the difference with, they are actually quite similar. So they both are a form of generics. The only difference is that this one makes sense only when you are implementing a trait and you want to fix a specific return type of that trait.
Yeah, because when you declare the trait, you have to specify what is taking and what is answering. So it's answering a self error. And here you are defining, look, self error is a parse error for my implementation of this trait. But to be able to refer to the return type elsewhere in a generic way, because they are generics, you have to specify this. It's not a type alias again, it's a type association. No.
Yes, and you might have wondered why didn't they do something like this, right? So they could have used another additional generic to specify the error type. The problem is that at that point you will be able to implement this trait for multiple types with different errors, and at that point it doesn't make sense anymore because now how you will need to specify also the error type that you expect when you try to call that trait.
Yeah, but at this point you will not be able to understand which implementation to call anymore.
Unless you tell it, you have to tell it, I want the implementation that returns me this kind of error rather than another kind of error, which is messy. Yeah. Here we want only one error type. So associated types makes sense.
Fixing char will give you a parse error where you try on token.
Another good example that we have seen before is in iterators. So when you define your own iterator, you are basically saying every time you call next, I want you to give me a particular type. But for a given iterator, you only want one type, like you fix the type when you implement the iterator. You don't want the iterator to have multiple generics types. So the associated types are useful when you want to fix the decision of a type and you don't want to have multiple implementation using different types. Or at least that's my understanding of them. If anyone in the chat knows other reasons or other cases where it's better to use generics versus associated types, let us know, because remember, we are here to learn. So if you feel you can add something, please do. Okay, so let's go now to the place where we use that.
Yeah, because now we can't use the from anymore. We are using a try from, and we have to unwrap basically.
So we need to use try from, try into actually, and this is not going to succeed because try into returns a result. So one thing that we can do is unwrap,
or handle it properly.
If we are unwrapping, this is just going to panic, right? At this point, whenever we find a character that is invalid. If we want to handle it properly, keep in mind that this function is already returning a result of a parse error. So the nicest way that we can use here is we can use map error. Or actually, I think we can just use the question mark, because we are already returning. So this function already, when it fails, already returns a parse error. So the question mark is a syntactic sugar that says, if this is an error type, just return a result of an error with that error.
So basically it's pushing the exception, sorry if I call it exception, but it's pushing the exception one level above in the stack of calls.
Now, if this one was exactly, it's just like almost like throwing. There isn't like the same concept, but it's, you can relate like a throw. If this one was a different exception type, a different error type, sorry, you could have used something like map error to say, if this is an error type, and you need to produce an error, a parse error type, you can do a mapping that way yourself. So this is useful if this function was something that we didn't write.
And you have to put a question mark at the end of that, or just a map?
And you still need to put a question mark, because you still want
it will
to
throw it will panic anyway if you use okay.
No, it's just that if you don't use this, it will still return a result.
Okay.
Instead, with the question mark, it's like you are unwrapping the result. And if it's good, you keep it. If it's wrong, you return. You bubble it up, basically.
Yeah, but we don't have to map error because the error, we are in the same class.
Exactly.
The error is of the same type. Sorry if I say class and I talk in object-oriented way. I know that Rust is not strictly object-oriented, but I need to map the concept somewhere.
And there is a good comment here. Thank you, Silence, for helping us to explore these ideas. So question mark also calls into for you. So if you had token error and implemented from token error for parse error, question mark could still be used. Oh, that's interesting. I didn't know that.
Okay, let me read it again. Also calls into for you. So if you had a token error and implement a from, okay, we have to implement the trait from for the token error.
Exactly.
That okay. Probably I understood. So instead of doing the map error, you can do you can implement the trait on top of the error type.
Yeah, I think the question mark, you can see it as, I'm going to write it here and we can clean up. Something like let result, and you call, I don't know, and you have here a type, and you call something like fallible, so something that can fail, and then you do question mark. Question mark is like you do unwrap. Actually, you get the result, and then you do if r of that result. Sorry, if r e of that result. I'll get there. Then you return the error. Return e, I guess. Otherwise, the else is basically you do something like x equal result dot unwrap into, I think, where you know already what's the type of x, because it's specified here as token, for instance. So you also know that information you are saying x as token, for instance.
Okay, and you do all of this with the question mark?
And I think that's what the question mark does.
I like the question mark.
Let me know if it's correct. I think here we have we have a better implementation of it. So match file, actually, I should have used the match statement. I think it's more expressive.
Yeah, instead of if else.
Oh, it also maps the error type. That's interesting. So into is also used for the error type. not for the actual type. So I don't think I got it correctly. Into is used on the error side. So it would be into here and not here. Here is just unwrap. Okay, so I understand how this is useful. So if we had a different type here, let's say this was a IO error, right?
Mhm. You have to implement the trait of the from the error to the parse error, and so it was getting converted on the fly.
And at that point, you don't need to use the map error. It will be converted on the fly.
Yeah.
Okay, that was really useful. Thank you, Silence. Please.
But you have to implement the trait on top of your error to map to the other error.
Exactly, yeah. So, but it's something you could do, I think, also with that crate. That crate I used, I think you have also shortcuts there. You can add annotations to do that automatically for you, if I remember correctly.
Because the enumeration of errors you're doing up there is with a specific macros from a specific crate that you imported. They are not out of the box.
No, that's a third-party crate that you need to install. It's called the one called this error. By the way, Jay Hugo, thank you for the follow. Oh, cool. This error macro also has something for chaining errors. Yeah, that's another concept that we are not seeing here, but because it's kind of a flat case. But imagine where you have a case where a failure is generated by another failure. So you kind of have to bubble up all this failure, which is kind of an idea of a stack trace in other languages. With that crate, you can create, I think it's something called source error, like the default error trait as a concept of source, like what was the source of that error. And you can use annotations to kind of easily chain errors together. So you could say this error will depend from another type of error. We should do maybe a dedicated stream on this stuff because
I think so, because I'm starting to get lost.
But it's basically in a kind of a flat way, they managed to re-implement the idea of throwable error, even though they're not really throwable, you're just returning, and stack trace, even though there isn't a concept of stack trace, it's just objects that contain all the previous errors.
But still, you can see what happened in your code. That is always nice.
Okay, so we still have a few errors because I think in the tests we are still using that into. Yeah, so here I'm just going to try into and unwrap. And this way we fix the test, and then we can add a new test where we actually have this error to see that it's actually failing in the way that it's supposed to fail.
Yeah, and it's throwing that error.
We should have used multi-cursor, but
next time.
Late. Oh, there are still
or copy and paste
now,
also. Not going super fancy with multi-cursor, just a old style copy and paste. No.
Okay, so now we want to do another case where we say
throw a random character in it.
Yeah, invalid char x, and we put the x here just because it doesn't make a big difference, and we put it here because that's just a comment. So what we expect, it doesn't matter, right?
We expect
how did I write this test? So we can just do parse of expression, and then here we need to match that the result is an error of invalid char, and the char is uppercase X. And I think we can remove all of this. I think that's it.
You made different tests?
And this is not mutable. No, I have everything in one big test. I was lazy. But what we can do is run it and see if it works, and then break it and see if it breaks.
Okay.
It seems that it's working. Now, if we change this X to C, for instance, it should tell us that it fails because it was expecting an X and it found a C. Let's see if it's descriptive enough.
Or if
no, it just says it failed.
the session failed, but doesn't say why.
It's saying that the character here was a C. So I think you can kind of infer that you were looking. Oh, no, this is what we said. Okay.
That is what you were expecting.
Yeah, you don't really know if you failed because the type is different or because the C is not C. Because this could have failed also if you got another error type.
Yeah. But in any case, it's failing, so fix it.
Yeah, I would have wished for a diff type of message where you could see exactly how the match failed, but in reality, I think
you are spoiled. You're spoiled. When you have an error, you debug.
There might be a different macro to do that. I think the problem is that here we are just asserting true or false, and of course, when you are asserting false, this will tell you it was false.
There is not an assert matches or an assert equal, an assert.
There might be. I'm not aware. If anyone knows, let us know in the chat if there is an
you can't assert equal result with error, no? Can't you?
You cannot, because I think at that point you need to use a match because you have. Oh, assert matches is nightly, so there is something like that. But
okay.
it's not
it's on the way.
Here. I hope that nightly implementation also gives you a nice diff, and it's not just a wrap for this one. If you know, let us know.
New macro is putting two macro together nightly.
Actually, we can search for that.
A little bit of effort, guys.
Just assert. I'm curious now. Oh, there is a crate. Okay. But I don't think that's the one. That is the official one. This is probably the official one. There is a beautiful macro that I cannot read this yet. Eventually, I'll be able to read macros. Yeah, but yeah, that's the point. So we should eventually get nicer error messages. Okay. Thanks a lot. So do we want to leave it at this for today? Or is there anything else?
1 hour. We go on with 50, with 11, see, with 15. We go 10, 15, then we do 11, 13. Jump around. No, we'll do 11 next time. Come on, let's try to be consistent.
Also, let us know in the chat or even later on Twitter or other channels if you're watching the recording, if you like this format where we try not to just do Rust, but also compare it with the languages that we know better. This time we did Python. Next time we might do a little bit of JavaScript as well. But yeah, let us know if you like this format better or if you prefer to stick only with Rust.
So you can find the recording on YouTube, like Luciano just said. The link is in the Twitch About session. If you are watching this on YouTube, we do live streaming every Monday on 5 p.m. UTC. Make sure to check 5 p.m. UTC. Yeah, no, we changed the daytime, daylight saving.
Now it's 6 p.m., right?
Now it's 6 p.m. UTC. Yeah, okay, 6 p.m. UTC. Sorry, guys, or not? Well,
it's still 5 p.m. UTC, I think. Well,
6 p.m. Dublin time. Let's put
it
this
exactly.
way.
You can find also the timing on Twitch as well. So
yeah, better. We are not software engineers. They are not good with dates. Make sure to check the Twitch link in the YouTube description. Give us a follow and everything else. Feel free to leave comment, open PR. Our repository is still on GitHub if nobody steal it. And
here you have the link.
Yeah, still here. Everything is well accepted. We are trying to learn Rust, so don't expect our solution to be the cleanest one or more idiomatic ones. If you know better ways, tell us. Thank you for all the support in the chat, all the suggestions to Silent Z that helped a lot today. Are we going to rate somebody?
Yes, we are going to rate the Primagen, which you probably know because he's one of the most famous coding streamer and one of the most engaging. So I hope you will have fun. See you next time.
He codes while jumping on top of a lava pit?
probably even worse than that. Yeah.
Yeah, cool. Thank you. Bye. See you next time.
Bye.